applied electricity, and we have a problem here to solve on concerning capacitor. And we see that a 30 microfarad capacitor is connected in parallel 80 ohms resistor across a 240 volts. We have 50 S supply. Then we have to calculate A, the current supply, B, the current phase of each, then C, the current phase angle, B, the current of each, then C, the current phase angle, then D, the current impedance, then E, the current expected. Now, before we solve, we have to bring out our values. Now we have a 30 microfarad, which is T equals to 30 times 10 raised to the power of minus 6. And we have 80 ohms, which is our resistor. So let me just put it like R is equals to 80 ohms. 80 ohms. And we have voltage V is equals to 240 volts. And we have S, which is frequency, is equals to, because S is measured in frequency, is equals to 50. So we have to calculate the supply. Now, for us to calculate the current supply, you have to use the current. So current is equals to V over R, which is the voltage divided by the resistor. So it's now equals to 240 divided by 80. Now put that in our calculator, that will give us 4. Okay, 3. So equals to 3. 240 divided by 80 is equals to 3. Now to get the IL, which is equals to V over XC. This is what the capacitor reactant is still equals to V over 1 over this FC. Now, if this capacitance, is 2 pi FC. But if this resistor, which is inductance, let me see, is 2 pi FA. But now we are dealing with capacitor, so we are going to use 2 pi FC. So let me clear this. So we are using 2 pi FC since we are dealing with capacitor. So here is going to be 2 pi FC. Now we have to equate this into a formula for us to solve this equation. So now it's going to be 2 pi F. This V become VC. Remember, this V is our voltage. The V is our voltage. Now let's apply this. 2 times pi is 3.142 times frequency, which is 50S, which is 50, times V, which is 240. Our voltage is 240. Then the capacitance 30, because it was stated that a 30 microfarad capacitor is connected in parallel. So the capacitance here is 30 microfarad, which is also known as times 30 times 10 raised to the power of minus 6. So we have to sum up this. 2 times 3.142 times 50 times 240 times 30 times 10 raised to the power of minus 6. So when we subtract this, everything is going to give us total is 2.262. So that's for A, the current supply. Now the current of each angle. Now let's solve for the current of each angle. Now I think IL is equals to the square root of I arrow square. You can close the bracket. I arrow square, then I. Since we are dealing with capacitance, IC square. So it's now equals to this I arrow square. Now is our first, which is 3. I arrow, which is 3. We're supposed to put arrow in. I arrow, which is 3. So it's going to be the square root of 3 square, then plus, then the plus here, then this IC square, which is our capacitance, which we just find, is 2.262. square. So let's increase this and see what it will give to us. So 3, let's simple this. So it's 3 square plus 2.262 square. So what we have here is 2.7557. So it equals to 3.757. That's what our current is now. 3.757. Now they say we should also look for the current phase angle. And the current phase angle is theta, which is tan theta, which is equals to tan 3.757. So we are going to impute tan 3.757, which is tan 3.757. That's going to give us, okay, since tan theta is tan 3.75, let's just take the tan inverse. So theta will going to be tan inverse of 3.757. Let's take the tan inverse. So shift tan. So if you want to take tan inverse in your calculator, you press shift tan. So shift tan 3.757 is equals to 75.09. So 75.09. Okay, now let's look for the current. So for the current phase angle. So the current phase angle is tan theta, which is equals to TC over TR, which is our TC, which is the current. TC is 2.262 over TR, which is, okay, let me say ICIR. Okay, that is over 3. So if we calculate this, 2.262 divided by 3, that's going to give us 0.754. Now we are going to take the tan inverse. So tan inverse, which is theta, is equals to tan inverse of 0.754. Then put it close. Equals to tan inverse of 0.754. So let me take shift tan to get a tan inverse 0.754. It's going to give us 37.01. So these are our theta. So theta is equals to 37.01. Now we have to solve for the current impedance. We have to solve for the current impedance. And the current impedance, which is Z, is equals to V over R. Yes, current impedance V over I. And our V is 240 volts. And our I is, sorry, not V over R, V over I. V over I. And our I is okay, 3.757. 3.757. So 240 divided by 3.757. That was going to give us 63.88. Can also approximate it to 63.9. So we've gotten our current phase angle degree. Let's put it on degree. 63.88 degree. So now we are going for the power dissipated. And the formula for power dissipated is, which is P is equals to V times I cos theta. So this is the formula for power dissipated. If you want to solve power dissipated. So our V now is 240 volts, which you all know. You can see check it there. So V is 240 volts times our I, which is 3.757 times theta is our theta, 37.01. So let me put it times cos, yes, so that we don't mistake. Times cos 37 point, which is cos theta, 37.01. Now let's increase this into our calculator. 240 times 757 times cos 37.01. That's going to give us 720. So our power dissipated is 720 watts. That's our power dissipated, 720 watts. So P is equal to 720 watts. So thank you for watching. Please don't forget to hit the subscribe button, like, and also share to your friends also. God bless you.